Our team really wanted to work with a local nonprofit and wanted to keep the home here and create the story about how a sustainable house can also be affordable. We're standing here in a collaborative project that's been worked together from 2 different universities for the past 3 years. The New School, which is Parsons School for Design, and Milano School for International Affairs and Management and Urban Policy Analysis, teamed together with Stevens Institute of Technology in New Jersey. Together, they created the Empower House Project. It was a 2011 solar decathlon entry. My role during the past 3 years was as operations director. I was working in budget and finance, working in procuring materials, also helping all contracts and documents run smoothly according to the new school policies. I was also working in development as the project progressed and was moved down to DC in its final location. We'd had over 97 different sponsors on the project, everyone from donating their time to helping to build on the site as volunteers with Habitat for Humanity, to donating materials, grants with the District Department of the Environment. Was one of our major sponsors. We had Intis Windows donated the windows. We had Columbia Forest Products for materials, Lowe's, Sheila Johnson and the Washington Mystics were one of our partners, and Jones Lang LaSalle. So we had some really great sponsorship there that I helped to organize and help to manage. There are many different features about this particular house that make it so special. The main feature, to me, I believe, is the partnership and the collaboration between the universities and DC Habitat for Humanity. Through the exhibition on the National Mall for the 2011 Solar Decathlon, that was the Department of Energy project. That, to me, is one of the major components. Our home, our entry, our exhibit was not just an exhibit. At the end, it was actually a home. It wasn't just a project that we put in and competed with, but it was a place where a family would live in. Through this partnership, DC Habitat is doing 6 more sustainable homes in the similar fashion as Empower House. They're doing 6 more passive homes in Ivy City, a neighborhood that is very underserved by DC standards. And it has always been a focus on Habitat for Humanity and other local nonprofits that work in affordable housing. We're slated to do 6 more passive homes. Passive houses typically save up to 90% on their energy costs for heating and cooling. This is a heat pump hot water heater. What the heat pump hot water heater does is, the way the students designed it, is that it's bringing in heat from existing appliances here, like the inverter, as well as heat coming from the dryer that the dryer produces. This is a ventless dryer, but it still produces heat. The machine itself produces enough heat that gets sucked through the ceiling, through a fan, and then dumped onto here. And this is will make it more energy efficient to create more hot water. Another water savings feature is the PEX home run supply system. Now what this does is that, so let's say in a typical home, I'll use my apartment for example. I live in an older apartment where it takes a little while for the water to run, and you run a little water for a little while and then you finally get hot water. What the typical construction is that you take the pipe from the hot water tank all the way throughout the house, and then you have offshoots coming straight off that pipe into each tap. So it'll take a little while for upstairs bathroom to get hot water because you're running through the entire house. This eliminates that. This is home run. So it takes it straight from the tank to the upstairs bathroom tap, to the downstairs bathroom tap, or to the kitchen for hot water. Here behind me we have the monitoring system. So we're looking at finding grants, and we're going to create a monitoring project for the home for the next 2 years for both homes. So what we're doing is we're connecting with our inverter, which is taking energy from the solar panels that are going to be on the roof, understanding how much we're producing, and then also understanding how much we're absorbing, how much we're using, how much energy we're using. And we're monitoring that systems with the homeowner and with Habitat for Humanity.
So through a grant with the District Department of the Environment, we're doing low impact developments here in the site. And what that is the stormwater management system. So we collect water, roof water, from the entire property, collecting the roof water down into a barrel here on the roof terrace where the homeowner can use to water the plants. And then the overflow is actually going under this bench and then out into 2 cisterns on both ends of the property. They're 1,000-gallon cisterns where the homeowner can use to water their gardens or to wash their cars for the property. Part of the low-impact development system we have with the District Department of the Environment was to create bioswales. What bioswales do is that it takes water, storm runoff water from the streets, and collects it into these systems. These plants are specific to this bioswale to absorb pollutants from the streets. The water is then filtered through sand and gravel underneath, and then is then clean enough. It's not potable, but it's clean enough then to go into the streams. Whatever overflow that we have from here is piped through under the house into rain gardens that we have on the back of the property. And it's the same process. Plants are there specific to absorb pollutants, and then we have gravel, and then sand, and then natural soil that's loose. And this is in an effort to reduce water runoff and storm pollutants to the tributaries that feed into the Anacostia River.